So now it's time for an actual lab. Hooray! So what we're going to be doing for this first lab, it's not just a lab to practice some of the safety techniques and methods that we talked about in class last time, but it's also a lab to learn how to use a tool that we're going to be using a lot this year. You can see it on the screen right here. It's called the LabQuest 2. Now the LabQuest 2 is part of what's called an electronic probeware system. Essentially, anything you can think of to measure temperature or motion or pH, that's a measure of how acidic or basic something is, they have an electronic probe you can use to measure this to help to get a more accurate and precise reading and to help really explore things that before were a lot more difficult to measure. So let's just take a look at the LabQuest 2 here real quick. There is a built-in microphone. There's a built-in light sensor. It's color touchscreen, just like a cell phone. Depending on which way you have it tilted, it will orient the screen that way. Built-in GPS, built-in Wi-Fi, 3 dedicated buttons, so very similar to a cell phone in that most of the activity you can do is on the screen, not with built-in buttons. There are connections for 2 digital probes, 3 analog probes, and a USB probe. So that's a total of 6 things you can connect at once. You'll never need to have that many. Power cord, it's also got battery, USB for connecting to computer, micro SD slot for storage, audio jacks, a couple of other jacks for different things. This device is pretty cool, as I hope you'll agree when we take a look at it. So it's got a lot of built-in things, but really what we need it for are all the sensors you can connect. Here's all the different things that you can connect to the LabQuest, and it turns out that we have a good number of these. Accelerometers, anemometer, that's used for measuring wind speed. We've got charge sensors, CO2 sensors, colorimeters, those can be used to measure rates of chemical reactions, conductivity, current sensors, dissolved oxygen, EKG can measure muscle activity or the electricity in your heart. Flow rate sensor we've got. Goniometer measures the angle that your joints make. Gas pressure sensors, GPS. Hand dynamometer, that's going to be grip strength. Light sensors, magnetic field, microphone, motion detector, oxygen sensors, pH sensors, photogates, radiation monitor, that's a new one we've got, rotary motion sensor, sound level, soil moistures, we've got temperature sensors, we've got ultraviolet sensors, we've got voltage probes, so almost anything you can think to measure, we have a probe that can measure it. So we will be using these a lot this year to help us explore more of chemistry. So this is going to be our first lab report in this class. So let's talk about for a minute what a lab report needs to have. Here's sort of a sample lab report that I put together, although it's also got directions in it. Now, in chemistry, your lab reports can be either handwritten or typed, your choice, whatever makes most sense for you, but they do need to have the following parts: name, date, and a descriptive title. By descriptive title, I mean not chemistry lab number 5 or just something that says, oh, LabQuest lab. A descriptive title. What did we do? There needs to be a purpose paragraph. A paragraph for me has at least 3 sentences. A sentence needs to be a good sentence. It needs to be meaningful. Pre-lab questions, if you have them. Write the question and the answer. Materials list. This should be a bulleted list including equipment that you used, including chemicals that you used. Procedures. This is what you did. It should be a numbered list, step-by-step directions. Should be good enough that someone who was not in class would be able to follow your instructions and do exactly what you did. Remember, repeatability is one of the hallmarks of good science. Data, a data table with what you measured. No calculations yet, no analysis yet, just the data. Data tables should be titled. Columns are good. Data tables are great ways to arrange data. Graph. When appropriate, you should graph. It won't always be necessary. I'll let you know. Remember that time is, if it's there, always goes on the x-axis. Different graphs for different things. Calculations, when necessary. Again, I will let you know. Post-lab question, if you have them. And then the conclusion section. This is going to be 4 paragraphs. First of all, results. What does your data mean? Needs to be a paragraph. Error. What went wrong? How could you improve the lab? More than 3 sentences you'll probably need for a lot of them. At least 3 good sentences. Connection to class. Why did we do this lab? Why today? Why was it important to what we're learning now? And a connection to the world. Why would anyone outside of the class care about what we did? The answer is not they wouldn't care. There's always a reason. So then your score for the lab will be all of these sections here. Again, sometimes you won't have pre-lab, sometimes you won't have graph, sometimes you won't have post-lab questions, but any of these sections present, I'm going to add them all up. They all receive equal weight, and that will give you your score. Okay, so in tomorrow's lab, let's just take a look at that real quick. Tomorrow's lab is getting to know the Vernier LabQuest. You can steal the title for this one if you want to. So the purpose is we're just going to learn how to use the LabQuest. Please don't just take this purpose, rewrite it in your own words. You do have a pre-lab question. We are going to be wearing goggles and aprons and gloves, even though we're not using any dangerous chemicals. So go ahead and say why. Materials. You're going to have the LabQuest, you're going to have a selection of probes, and you need internet connection to get to the website of Vernier, the company that makes the LabQuest. And then you've got a bunch of different things that you're going to do. Some of them online, some of them with the LabQuest itself. We'll go over this again tomorrow in class. And your procedures should also list how you actually found the answers in Part B. What did you do to find the year that helium was discovered? What did you do to find the current room temperature? And again, your steps should be clear enough that someone who wasn't in class could do the lab. That's going to do it for today. Fairly short video today because a lot of this stuff is things that we're going to do in class. I could go on and on about how great the LabQuest is and all the things you can do with it, but it will make more sense when you have it in your hands and you're able to play around with it. Don't forget to do the whisk.